So today's lecture we will discuss about analysis of clocked synchronous sequential network. So this is the general structure of our analysis procedure of a clocked synchronous sequential network. So today we will discuss about analysis of clocked synchronous sequential network. Okay. So for this analysis we have to follow a procedure, and that procedure I drawn it in a tabular column. So these are the procedure you have to follow to analyze a clocked synchronous sequential network. Okay. So first stage is logical diagram. Okay, this analysis of clocked synchronous sequential network is actually a university question. Okay, so you have to study this. So first stage is logical diagram. So next is assign state and excitation variables to each flip-flop. Third is excitation and output equation. Next is transition equation obtained by applying flip-flop characteristic equation, excitation table, transition table, state diagram, like that it is going. Okay, so first is logical diagram. Logical diagram, you have to draw the logical diagram. Sometimes it is given in the question paper. They are giving the logical diagram. You have to analyze this clocked synchronous sequential network. So logical diagram is there. What you have to do is you have to assign the states and excitation variables to each flip-flop. Okay, you have to assign the state and excitation variables to each flip-flop. Now then excitation and output equation, you have to write the excitation and output equation. So our aim is to go to the transition table, from the transition table, state table and state diagram. So you have the excitation and output equation. You have two ways to reach to a transition table. You have the excitation and output equation. You have two ways to reach this transition table. One is write the transition equation. From the transition equation you can write the state table, or another method is you can write the excitation table. From excitation table you can write the transition table. These are the two ways which you need to go to the transition table from the excitation and output equation. Okay. So after writing the excitation and output equation, you write the transition equation. How to write the transition equation? This transition equation is obtained by applying flip-flop's characteristic equation. Okay, you should know the characteristic equation of the flip-flop. From that you can write the transition equation. Then you can write the state table. From the state table, you can write the transition table. From transition table you will be able to get the state table. From state table you will be able to draw the state diagram of the machine. Okay. Or another method is excitation and output equation. From that you can write the excitation table. From excitation table you can write transition table. From transition table, state table, followed by, then finally it reaches to state diagram. Okay, this is the question. So in question paper they are given circuits like this, and they will ask for analyze the circuit like that it is going. So we have to analyze this circuit. So analyze the clocked synchronous sequential network. Okay, so look at the diagram. First you should understand whether it is a Mealy circuit or a Moore circuit. Okay, by looking at the diagram itself we can understand whether it is Mealy or Moore. How? Look at the output. This is output. Okay, so output, it is actually an OR gate output. It comes from two AND gate, and one input of AND gate is X. Here X is input. Okay, X is nothing but input, and flip-flop output is the states. So output depends on present state and input. So it is a Mealy circuit. So after getting this diagram, you have to, first step is you have to assign the state and excitation variable to each flip-flop. So we have two flip-flops. So we have to write this flip-flop 1, flip-flop 2. This is D. It is given, so you have to write D1, D2. So this is Q1, Q1 bar, Q2, Q2 bar. This is Q2 bar. Okay. So these are the first stage, assign state and excitation to each flip-flop. Next is write excitation and output expression. Step 1, write excitation and output expression. Okay, so for that look at the diagram. Before that going to detail, you have to look at the diagram. See, so look at this. This is the Mealy model of the clocked synchronous sequential network. Okay, so here I told that the input first is given to next state function if it is a combination logic, then memory or clocked flip-flop, then output function. It is actually a combination logic, then output. So output depends on this present state and this input. Okay, so first is a logic circuit, combination logic. Last is also a combination logic. In between we have a memory circuit. This is the Mealy model. Okay. Now look at the diagram. Same as it is. First it is a combination logic. First block is a combination logic. So these are the first block, combination logic. Output of this combination logic is given to a flip-flop. So this is the memory unit or flip-flop, second stage. And last stage is also a combination logic. It is nothing but a digital circuit, and output is taken from here. Output depends on present state of the flip-flop and input X. So it is a Mealy circuit. Okay. Now you have to write the excitation and output expression. How to write the excitation and output expression? So here the excitation is, first one is D1 and next is D2. These are the excitation, then output is Z. What is D1 here? What is D1 here? Look at D1, it is an OR gate. So D1 is equal to, how we can write D1? Two inputs, first from this AND gate, one input from this AND gate, another input from this AND gate. So you can write X bar. Here it is. D1 is nothing but X bar, and another input is that comes from this input, that comes from here only. So Q2 bar. Okay. See, this is first input. You have to write D1. D1 or this is actually output of OR gate. OR gate have two input. You have to add this, then you will get the D1. So D1 is equal to X bar into and Q2. See Q2. So X bar Q2 bar. D1 is equal to X bar Q2 bar plus another input is here. Here it is Q2 and Q1. So here this input is Q2 and Q1 bar. So D1 we can write it as D1 is equal to X bar Q2 bar plus Q1 bar Q2. You got the idea? So D1, like that you have to write D2. This is D2. How to write D2? This is D2. This is D2. How to write D2? How to write this D2? See, D2 is here. How to write D2? Two inputs. Okay. D2. First one is this input. This. So X into Q1 bar. This is X here, and this is Q1 bar. So X into Q1 bar plus this AND gate output. Q1 bar, Q2 bar. This AND gate output is nothing but one input is Q2, another one is Q1 bar. So Q1 bar, Q2 bar here comes. So D2 is equal to, how can we write X into Q1 bar plus Q1 bar Q2. So next is Z. Next is Z. What is Z here? Z is output. So Z we can write directly X bar Q1 plus X Q1 bar. Okay. So how it is written? X bar Q1 plus X Q1 bar Q2 bar. So how it is? X bar Q1 plus next is Q1 bar Q2 bar X. Three inputs are here. Okay, three inputs. So Z is equal to X bar Q1 plus Q1 bar Q2 bar X. That's why it is written is equal to x bar q1 plus x q1 bar q2 bar. So step 1 is over. Now step 2, transition equation. What is transition equation? It is the algebraic expression of next state of the flip-flop obtained by substituting the excitation expression of the flip-flop into the characteristic equation. See what is step 2? It is transition equation. You have to write the transition equation. To write transition equation, so it is actually a algebraic expression of next state of the flip-flop. Okay, this transition equation is nothing but next state of the flip-flop, and how you will get this transition equation? You have to write the characteristic equation. First write the excitation of substituting the excitation expression into the flip-flops into its characteristic equation. So you first write the excitation expression. You already wrote. You already see this excitation expression. Okay, you substitute this excitation expression into the characteristic equation. You will get the transition equation. Okay, so this is the excitation expressions. d1 d2 are the excitation, right? So these are the excitation expressions, d1 d2. Now you need transition equation. For that you need a characteristic equation of d flip-flop. You know d flip-flop characteristic equation, next set of the flip-flop is d only. Okay, so substitute this characteristic excitation expression into this characteristic equation. Okay, instead of d you have to put d1. Okay, this is the characteristic equation, general equation. So you have to put the excitation expression, this excitation expression, into this characteristic equation. Okay, so this is how transition equation is wrote. So you know what is q plus is d. Okay, that is a characteristic equation. Substitute the transition excitation expression into the characteristic equation. q1 plus equal to d1. Instead of d you can put d1 and d2, because here we are writing the characteristic equation d1. What is d1? X bar q2 bar plus q1 bar q2, and q2 plus is d2 equal to x q1 bar plus q1 bar q2. Okay, step 3, transition table. Step 3, transition table. This is the transition table. Here you have present state q1 q2, next state q1 plus q2 plus input is x is 0 or 1, output is z for input x 0 or 1, like that it is writing. Okay, so first is present state. You know what is present state? Can be 0 0 0 1 1 0 1 1. Okay, next state, you have the present state. You give an input. What is the next state? Input is x here, and it can be 0 or 1. For 0 input, what is the next state? So 0 input, what is the next state? You have the equation q1 plus equal to x bar q2 bar plus q1 bar q2. So you have to find this next state, and that equation is written here. You have the input x1 x, and you have the q states here. So substituting the value of q state here and the inputs here, you will get q1 plus and q2 plus. Okay, so next state, first you need to find out q1 plus. For the input 0, what is q1 plus? So x is 0 here, so substitute 0. Here it is x bar, so it is 1. X is 0 here, so we are taking x bar, so it is 1. q2 bar, it is q2 is 0, so q2 bar 1, so 1 plus q1 bar. What is q1 bar? 1, and q2 is 0. 1 into 0 0, so 0 plus 1 1 only. So for input 0, q1 plus is 1. Next is what is q2 plus for 0 input? So q2 plus is x q1 bar plus q1 bar q2. Here input is 0, so x is 0, so this time is 0, and here q1 bar is 1, q2 is 0, thus this time is also 0, 0 plus 0 0, so that's why it is 0 here. So for 0 input we wrote this. And what about 1 input? What is the necessity for 1 input? For that you have to write, again you check this equation for 1 input. Here x is, now this time x is 1. Okay, now this time x is 1, so you put x equal to 1. If you are at x bar, so this time is 0, and q1 q2, q1 bar q2, q1 bar is 1, q2 is 0, so this term is 0, 0 plus 0, 0 for q1 plus, so q1 plus it is 0. What about q2 plus? You have to write next input is 1, consider q2 plus x q1 bar, here x is 1, so 1 into q1 bar is 1, 1 into 1 1 plus q2 is 0, so this term is 0, 0 plus 1 1, so 0 1. Okay, so what is the output expression? Output is Z for input x equal to 0. What is the output? So you know output equation x bar q1 plus x q1 bar q2 bar. Here input x equal to 0, here it is 1, x bar, so it is 1, 1 into q1 is 0, so this term is 0. Okay, and here next here x equal to 0. Why? Because we are taking off 0 input, 0, so this term is also 0, 0 plus 0, 0 only. Okay, now x equal to 1. What is the next output equation? Z equal to x bar, this is the output equation, here put x equal to 1, so x bar is 0, so this term is 0, here x is 1, so this is okay. q1 bar q2 bar is also 1 1, so this term is 1, 1 plus 0 1, that's why it is 1 here. Clear? So for next state, what you have to do, you have to write the transition table. For transition table, this is a transition table. So it is a present state, next state, output table. Present state you know, input you know, you write next state. From how to get next state, you have the expression. How to get output, you have the expression. What you have to do, you just substitute the inputs and present state to this equation, you will get next state and output. Like that you have to proceed. Okay, consider one more example I will show. 0 1, for 0 1 input, what happens to the next state and output? For 0 1 input, present state input is 0. What is the next state? X is 0, so x is 0, this is 1, here it is 0 1, so q1 bar is 1, q2 is 1, so it is 1 here. Why? Because 0 plus 1 1. Now for q2, x is 0, q2 x is 0, the same is 0, and here it is 0 1. Okay, here q1 bar is q is 7 is 0, so q1 bar is 1, q2 is 1, so 0 plus 1 1, that's why it is 1 1. Now one input came. For input x equal to 1, what is the next state? Let's check. For x equal to 1, here x equal to 1, so this 1 bar, here 1 bar we are taking, so it is 0, this term is 0. What is q1 q2? q1 bar, q1 is 0, so q1 bar is 1, q2 is 1, 1 into 1 1, so 1 plus 0 1, that's why it is 1 here. Now what about q2? Next you have to find out next term also. Okay, so q2 is x q1 bar plus q1 bar q2 bar, x is 1, so 1 into q1 bar, q1 is 0, so q1 bar is 1, 1 into 1 1 plus again 1, q1 bar is 1, q2 is 1, so 1 plus 1 1, that's why it is 1. Now output is equal to 0, x equal to 0, what is Z output? X equal to 0, so here it is 0. Why? Because q1 is 0. Here x equal to 0, this time is 0, 0 plus 0, 0 here. Next input x equal to 1 input, what is the next state? So here x equal to 1, so this time is 0, because x bar we are considering, so this is 0. And this q1 bar, q2 bar, one time q2 bar is 0, so this time is 0, 0 plus 0, 0 here. Like that you have to proceed. Okay. Next is another method. See, I told that this excitation expression you have to write the transition table. For writing transition table, you have two ways. One is transition equation, then transition table. You write the transition table from transition equation, what we have seen now. Now another method is there, write the excitation table. From that you have to write the transition table. That is I discussed here. This is an alternative method. You can either follow this way or this way. It is up to you. Okay, which method you will get your convenient, you can follow that. Okay, this is the method I shown. Now I am going through this way. Another method for writing this state table. Okay, another method for writing the table. After excitation expression, write the excitation table, then write the transition table. Okay, first you write the excitation table. These are the equations. Excitation table is Q1 Q2 input X. What is the next state? D1 D2 and Z. For 0 0, for X input to 0, what is the necessity and output? For 0 0, for 1 input, what is the necessity and output? Like that you have to write the transition state excitation table. Excitation table, you know what is excitation table. So Q1 Q2 0 0, for input to 0, what is D1? You substitute the values here. For Q1 Q2, you substitute here. X value you substitute here. 0 complement 1. So 1 into 1. Q2 is also 1. Q2 bar is also 1. So 1 to 1, 1 plus. Q1 bar is 1. Q2 is 0, 0. 1 plus 0, 1. Like that you have to write this complete terms. Okay, D1, D2, Z. And then you will get this excitation table. From excitation table you write the transition table. Okay, how to write the transition table? How to write this transition table? Since here what you have to do is, since excitation table, since it is D flip-flop, transition table is same as that of excitation table. Okay, for D flip-flop, this transition table is same as transition table is same as that of excitation table. Why? Because for D flip-flop, the necessity expression and characteristic equation both are same. Q plus is D. We have seen what is the characteristic equation. Q plus is D only. That means necessity is nothing but D only. So for D flip-flop, transition table is same as that of excitation table. What you have to do, you just substitute. Instead of D1 D2, you can put Q1 plus and Q2 plus. Why? Because characteristic equation is like that. Necessity is nothing but D only. So how to write the transition table? Present state, necessity Q1 Q2, output Z. Okay, so look at the first. You have 0 0 input. Okay, you have 0 0 input. For X input to 0, what is for X input to 1, what is necessary? For X input to 0, what is the output? X equal to 1, what is the output? Like that. Okay, so here look at here first. You just write here values from this table. Okay, so 0 0 for input to 0, 0 0 for input to 0. What is this D1 D2? You write Q1 and Q2. What is Q1? What is Q2? For 0 input, 0 0 0 input, Q1 is 1, Q2 is 0. 0 we write here. For input 1. For 0 0, for 1 input, what is Q1? 0. What is Q2? 1. So it is 0 1. So 0 0 0 input, what is output is Z. For 0 0 0 input, output is Z is 0. So output is Z is 0. What is for 1 input output? For 0 0 1 input, Z is 1. So you write Z is 1. Like that, from this table you write all the expression to this table. Clear? You just transfer the terms to here. That's only the thing. Okay, and finally you write the state table. How to write state table? First assign states. For 0 0, I am assigning state A, 0 1 state B, 1 0 C, 1 1 D. Now present is our state transition table and writing with the states. Present state next is Z. For this is for input X equal to 0, X equal to 1. For present state A, 0 0, first is A, B, C, D. Why? Because 0 0 0 1 1 0 1 1. These values you will get from that this expression. Okay, this table I am transferring. For 0 0 I am putting A, 0 1 D, 1 0 C, 1 1 D, like that. 1 0 C, 1 1 D, 1 0 C, 0 0 A, like that you have to write. Okay, so C, D, C, A, like that states you have to write. Instead of this value you put this states to here. Output is same. Okay, now draw the state diagram. How to draw the state machine? You have 4 states A, B, C, D. So you will write 4 states A, B, C, D. Okay, so A is the present state. Okay, this is the next state arrow. Okay, first letter indicate the input, after the slash next letter indicate the output. Okay, this is input, output. This arrow indicates the next state. Okay, now look at here. For state A, I am giving 0 input. What is the next state? C. Okay. For state A, for state I am in state A, I am giving 0 input. For state A, I am giving, look at here, for state A, I am giving 0 input. What is the next state? C. For state A, I am giving 0 input. It will be changes to next state C. Like that it is drawing. So I write C, next state, for 0 input. At that time, what is the output? At that time, for A input 0, for A state 0 input, what is the output? Output is also 0. So I write 0 bar 0. 0 input, 0 output. It will changes to state C. Okay. What happens if I am giving 1 input to state B? Sorry, state A 1 input. State A 1 input, it will go to state B. So 1 input, it will go to state B and output is 1. Why? Because here output is 1. State A 1 input, output is 1. Then now we drawn 2 lines. Then now what? B. For B input, so B is the present state. Now B is the state. For 0 input, it will changes to state D. So B input 0, B state 0 input, B state 0 input I am giving. It will changes to D state, and what is the output? 0. Why? Because B input 0 കൊടുത്താൽ D ആയിരിക്കും. B inputൽ B is the state, 0 input കൊടുത്താൽ 0 is the output. That's why I am writing like this, 0 by 0. Now this much two rows I wrote. Now state C. For state C, 0 input, next state is C only. So state C, for the state C, 0 input. For the state C, 0 input, I am getting 0. For the state C, this is the state C. I am giving 0 input, it will goes to C only. So it is a self loop. And what is the output? Output for 0 input, C, 0 input, output is 1. Okay. So 0 bar 1, like that. 0 bar 1, it is written like this. 0 bar 1. Okay. Now you are in state C and I am giving 1 input. State C 1 input, it will go to state A. State C 1 input, it will go to state A. So for state C 1 input, it will go to state A. What is the output? State C 1 input, output is 0. So 1 bar 0. Okay. Now we are in state D. For state D, 0 input, it will go to state A. State D 0 input, it will go to state A. So like that you have to go. State D 0 input കൊടുത്താൽ it will go to state A. State D 0 input കൊടുത്താൽ this is 0 input, it will go to state A. And what is the output? D 0, output is 1. So here it is 1. Now state D 1 input, what is the next state? State D 1 input, at that time also A only. So you can write 0. After a comma you can write 1 bar 0. So for 1 input it will go to, so 1 input it will go to state A. For 1 input it will go to state A and output is 0. So 1 input, output is 0. Like that you have to draw this state machine from the state table. Okay. And this is one of the most important area in analyzing clocked synchronous sequential network.